Hello everyone. So now we will start the multiple integral and its application. So before you going to the multiple integral and its application, actual part of multiple integral, before we see or we recall the sum of the basic formulas of the integration. So some of the basic formulas of the integration, here are the basic integration formula. That is integration of dx is equal to x plus c. Then integration of, this is the main formula, it is integration of x raised to n dx is equal to x raised to n plus 1 upon n plus 1. Then integration of e raised to x plus c is equal to e raised to x plus c. And some of this, the basic integration formula, it is e raised to integration of e raised to x dx is equal to e raised to x upon a. Then integration of a raised to x dx is equal to a raised to x upon log a. One of the basic formula is integration of sin x dx is equal to minus cos x plus c. Integration of cos x dx is equal to sin x plus c. So now the next formula is the integration of tan x dx is equal to log of sec x plus c. Then integration of cot x dx is equal to log of mod of sin x plus c. Integration of sec x dx is equal to log of mod of sec x plus tan x plus c. And integration of cosec x dx is equal to log of mod of cosec x minus cot x plus c. Okay, so this is the sum of the basic formula. There are lots of the basic integration formula, but we actually use this formula is in multiple integration. Okay, so some of the basic formula, not all, but the product rule is uh, the main formula of the integration is the product rule. So in the last or in the differentiation, there is no any restriction that which will take you the first term and the second term. But in the integration, it's the main part is decide the first term and the second term. So we decide this at on the basis of the LIAT rule. So L is the logarithmic function, that is the log x function. I is the inverse logarithmic, that is sine inverse x or cos inverse x, so that type of function. Then a is the algebraic, that is x and all type of function x or x square plus 1. T is the trigonometric, that is we all of you know that sin x cos x, so that type of function. And e is the exponential, so exponential, that is the e raised to x and all. So what is the integration formula? If I am decided this is the first term by using the LIAT rule and this is the second term, so the integration formula is first into, that is first into integration of second, that is v term, minus integration of derivative of first into integration of second. Okay, so that is the u into integration of v minus integration of derivative of u into integration of v. Okay, so now we are going to, so this is the basic example of the double integration. So how we solve this integration is integration 0 to 1 dx dy. So how we solve? So there is a no any restriction that which will take the first, that is with respect to x and with respect to y. Why? Because the upper limit and lower limit are only the constant term. Okay, so not a constant term, constant limit. Okay, so that is if I am taking the first with respect to x, so integration of 0 to 1, then integration of 0 to 1 dx, then dy. So is equal to into integration of 0 to 1. So in the basic formula we see that we already seen that integration 0 to 1 dx is the x and limit is the 0 to 1 dy. So is equal to integration 0 to 1. So upper limit minus lower limit is 1 minus 0 dy. So is equal to integration 0 to 1, 1 minus 0 dy, that is the 1 dy. And what is the integration of 1 dy is 1. And again taking the limit 0 to 1. So is equal to 1 minus 0 is equal to 1. Okay. So again, if we want to take first integration with respect to y, no problem. We solve this example and we check the answer is same or not. So this is the, if I am taking integration 0 to 1, integration 0 to 1, first we take integration with respect to x, now we take integration with respect to y and then x. So is equal to integration 0 to 1. Okay, so what is the formula of the integration of dy? That is y. So 0 to 1 dx. Okay, so integration of 0 to 1 upper limit minus lower limit dx. So is equal to integration 0 to 1 dx. So what is the integration of 1 dx is x. Okay, is limit 0 to 1. So 1 minus 0 is equal to 1. So because of the constant limit, so there is a no any restriction that which will take the integration with respect to x or integration with respect to y. So this is the one of the basic example in the double integration. Now we are going to the second example. So now in the last example, both the limits, both integration limits are the constant, okay? But in this integration, the first integration limit is 0 to 1, but the second integration limit is 0 to x. That is the upper limit in terms of the x. So at that time, when the upper limit in terms of x or the lower limit in terms of x, so that time we are taking the integration with respect to y first. Okay. So firstly we integration with respect to y. So integration 0 to 1, integration 0 to x, xy, first dy, and then dx. Okay, so now is equal to dx. Okay, so now next is the integration 0 to 1. So at that particular this integration x is treated as constant. So integration 0 to x y dy and then dx. Sorry, okay, dx. So now is equal to integration 0 to 1 x as it is. What is the integration of y? Integration of y is y square upon 2. Limit is 0 to x dx. Okay. So what is then upper limit minus lower limit? So is equal to integration 0 to 1 x as it is. Upper limit is x, so x square upon 2. Lower limit is 0, so that is 0 dx. So is equal to integration 0 to 1 x into x square is x cube. So x cube upon 2 dx. So next line is equal to 1 upon 2 is the constant term. So integration 0 to 1 x cube dx. So what is the integration of 1 x cube is? So x cube integration is x raised to 4 upon 4. Limit is the 0 to 1. So is equal to 1 upon 2 into 1 by 4. Upper limit is 1. So 1 by 4 minus 0. So the final answer is 1 upon 8. Okay. This is a dx. Okay. So how we solve? Recall one thing that if the limit in terms of x, okay, so at that time we take the integration with respect to y. Firstly, we take integration with respect to y. So here integration 0 to 1, integration 0 to x, xy, dy and then dx. So at this particular this integration, x is treated as constant. Okay, so integration 0 to x, y, dy then dx. So integration 0 to 1 x as it is. What is the integration of y? So y square upon 2 0 to x. So that is upper limit minus lower limit dx. So x cube upon 2 dx. So 1 upon 2 is a constant. Take outside of the integration. So 0 to 1 x cube dx. So is equal to 1 upon 2. What is the integration of x raised to x cube is x raised to 4 upon 4 and limit is 0 to 1. So again 1 by 2 upper limit minus lower limit. So is equal to 1 by 4 into 1 by 2 is equal to 1 by 8. So this is the final answer. Now we are going to the next example. So next example is in the form of the polar. Okay, the last example in the terms of the Cartesian form. So this example is in the term of the polar form. So in the polar form, we see that the integration 0 to 1 that is a constant limit and integration 0 to pi by 2. So if the integration in terms of the angle, that is the 0 to pi by 2, 0 to pi by 4, so obviously we are taking the integration with respect to theta. That is a trigonometric function integration. Okay, so that is integration 0 to 1, integration 0 to pi by 2 r sin theta d theta dl. So is equal to integration 0 to 1. Okay, so at this particular this integration r is treated as constant. So integration 0 to pi by 2 sin theta, sorry, wait, sin theta d theta and then dr. Okay, so is equal to integration 0 to 1 r as it is. What is the integration of sin theta is minus cos theta, limit is 0 to pi by 2 dr. Okay, so is equal to integration 0 to 1 r as it is, upper limit minus lower limit, that is cos of minus cos of pi by 2, and upper limit minus lower limit, so minus minus plus cos, wait, upper limit minus lower limit, so cos of 0 d. So is equal to integration 0 to 1 r. What is the cos 90 is 0 and cos 0 is 1. So dr. So is equal to integration of 0 to 1 r dr. So what is the integration of r is? Integration of r is r square upon 2 and the limit is 0 to 1. So the answer is upper limit minus lower limit. So 1 by 2 minus 0. So the final answer is the 1 by 2. Okay. Again, or I recall the example is if the integration in terms of the pi by 2. Okay. Here the first integration in terms of the pi by 2. So at that time we take the integration with respect to theta, and if integration with respect to a constant term, then we take the integration with respect to r first. Okay, so that is integration 0 to 1, integration 0 to pi by 2, r sin theta d theta dr. So for particular this integration, r is treated as constant. So integration 0 to pi by 2 sin theta d theta dr. So what is the integration of sin theta? We already seen in the basic formula. That is the minus cos theta. Limit is the 0 to pi by dr. So r is the minus cos pi by 2 upper limit minus lower limit, but minus minus is plus, so cos 0 dr. So r into bracket cos 90 degree is 0 plus 1 dr. So that is the r dr. Then integration of r is r square upon 2. So 0 to 1. So 1 upon 2 minus 0. So the answer is the 1 upon. Okay. So now we solve this the integration 0 to pi by 2, 0 to a cos theta r sin theta dr d theta. Okay, so the limit in terms of the a cos theta, there is no any angle. So we solve this integration first way with respect to r. Okay, so first way with respect to r, then after that integration with respect to theta. So that is integration 0 to pi by 2, then integration 0 to a cos theta r sin theta. First we solve the integration with respect to r and then with respect to theta. So is equal to integration 0 to pi by 2. For this particular this integration, sin theta is the constant. So sin theta integration 0 to a cos theta r dr, and then next is the d theta. So is equal to integration 0 to pi by 2 sin theta as it is. Integration of r is the r square upon 2, 0 to a cos theta d theta. Okay, so is equal to integration 0 to pi by 2 sine theta as it is. Integration upper limit minus lower limit is a square cos square theta divided by 2 minus 0 d theta. So we are getting integration 0 to pi by 2 a square upon 2 into sine theta into cos square theta d theta. Okay, so after this we solving using of the two method. So first is the reduction formula. If anyone knows about the reduction formula, so we already seen in the last unit, that is the reduction formula. So that is the reduction formula. What is the reduction formula? So the reduction formula is, if the integration is 0 to pi by 2 sine raised to mx into cos raised to nx dx, then the formula is subtract 1, 3, 5 up to and so on from m, that is m minus 1, m minus 3 up to and so on. Solve this up to we get the either 2 or 1. Okay. Similar way for the n, subtract odd term from the n, so we get 2 or 1, that is n minus 1, n minus 3, 2 and so on, 2 or 1. After getting 2, either one, we stop here. Then next is the addition of the m plus n, and then subtract all the even term from the m plus n, n plus n minus 2, and solve up to we get either 2 or 1. Then we stop here, and then overall, okay, and then total overall multiply by 1. Okay, overall multiply by 1, that is, this is the uh, after multiply by 1. And what is the value of k? If the m and n both are the even, then the value of k is the pi by 2. So this is for m or m and n are even, and for is equal to 1 for the otherwise. Okay, so this is the reduction formula. So for this, by using the reduction formula, we solve a square is the constant term, so taking the outside, and sine m value is 1, so we stop here, that is the 1. N value is 2. We know that, we already seen that either 2 or 1, but if I am subtract 2 minus 1, then the answer is 1. So either 1 or 2, that is the minimum value is 1, so we stop here 1, and then m plus n, that is the 2 plus 1 is 3, so 3, then 3 minus 1 is 2, right? So 3 minus 2 is 1, so now we stop here, and after that 1 is m is, that is right here, m is equal to 1 and n is equal to 2. So that is the 1 even and 1 odd. So the value of k is equal to 1. So after we solving this, answer is a square upon 6. Okay. But those who don't understand the reduction formula, so we obviously solve this example in terms of the by using the substitution method. So a square upon 2 integration 0 to pi by 2, right? 0 to pi by 2 sine theta into cos square theta d theta. Okay, so substitution method is substitute cos theta is equal to t or x. So derivative of cos theta is minus sine theta, d theta is equal to dt. Change the integration. So when theta is equal to lower limit is theta is equal to 0, implies cos 0 is equal to 1, and when theta is equal to pi by 2 implies t cos pi by 2 is 0. So put this value, so a square by 2 is as it is, a square by 2 is as it is, and integration of 0 to pi by 2 is changed as the integration 0 to 1, sorry 1 to 0. Sin theta d theta is the minus dt, and cos square theta is t square minus dt. So is equal to minus a square upon 2 integration 1 to 0 t square dt. Okay, so is equal to minus a square upon 2 as it is. Integration of t square is t cube upon 3. Limit is 1 to 0. So is equal to minus a square upon 2. Upper limit minus lower limit, so 0 minus 1 upon 3. And after solving this, we get a square upon 6. So we solving this, after this, we solving by substitution method as well as the reduction method. Okay, so I will hope you understand all this, the basic example of the double integration method. After then the next video, we see the finding the area of the curve. Okay, thank you all of you. Thank you.